Welcome back to my channel. In this video, we are going to be talking about the application of first order differential equation to temperature, okay? And then we are going to be using the Newton's law of cooling to solve this particular question. And then you should know that the Newton's law of cooling is equally applicable to heating. And it states that the time rate of change of a temperature of a body is proportional to the temperature difference between the body and its surrounding. Okay, so it says that what the rate of change of temperature with time is directly proportional to the what the change of that temperature with the temperature of its surrounding. You should note this, very, very important. So if you remove proportionality sign, we're going to be having that dt, okay, will now be equal to what? K into, or we can say R. Some people use K, some people use R. R into T minus what? Tm. Okay, where R is the rate of increase. So now, where Tm is known as what? The temperature of the surrounding, and then the T here is the current temperature of the body. Okay, having this, with this we can solve this. If you look at it, they will say that a metal bar at a temperature of this. So if we bring out our parameters here, we will be seeing that the temperature of this body is 100 degree Fahrenheit. Okay, is placed in a room at a constant temperature of 0 degree Fahrenheit. That is the temperature of the surrounding is now 0 degree Fahrenheit. Okay, and then I say that if after 20 minutes, so the time is 20 minutes, now the temperature of the bar is 50 degrees. Now the initial temperature of this body is 100. This is the initial temperature of this body. Okay, and then they say that the current temperature now will now be what? 50 degree Fahrenheit. That is after 20 minutes. They now ask us to find the time it will take this. Let me close here because of. Okay, they now say that we should find the time it will take this bar to have a temperature of this. Okay, solution. Having this, now let us apply the ones we know. We know that the T over what? The T is equal to what? Let us put our this. You have R into what? The T we don't know minus, okay, minus the room temperature is 0. Okay, so here we're having that what? The T over the T is equal to RT. This is separable. Since it's separable, I'm having the T over T is equal to what? R dt. So if I integrate both sides, I'm having that the ln T will now be what? The integral of R dt plus a R dt. Okay, that is if we integrate. Okay, let us integrate both sides. The integral of 1 over T dt is equal to the integral of R dt. So I'm having that ln T is equal to what? Is equal to RT plus a constant. So T itself will now be what? Exponential RT plus a constant. So T will now be what? Exponential RT multiplied by exponential C. So therefore T becomes T naught exponential RT. Okay, for this particular one. So if I apply this, I'll be having that. Let us get the rate at which it increases, because we cannot find the rate here. So from what we are given, they say that the initial temperature of this body is 100. Okay, so we now have that the initial temperature is 100, and then the current temperature is 50 in 20 minutes. So we have that 50. We're going to have that 50 is equal to 100 exponential 20 times R. That is 20R. Okay, so we are going to have that this is exponential 20R will now be 50 divided by 100. So exponential 20R will now be what? Half. So 20R will now be ln half. Okay, so therefore R will now be what? Ln 1 over 2 over what? 20. So the rate at which this increases is going to give us. So do the math and tell us what your own answer is. I'm not here with my calculator, so let me see what we're having here. Right? So we're having at the rate at which it increases becomes okay, the rate at which it increases becomes, Sorry, I think there is a mistake somewhere here.